All right, let's dive right in. There's a huge problem happening in enterprise AI. We're seeing these brilliant, incredibly accurate models fail to make it into production. And it's not because they're wrong. It's because security was treated like an optional add-on. So today, we're not just going to list some rules. We are going to architect an entirely new foundation built on trust. This quote right here, it just nails the problem, doesn't it? I mean, how many of us have seen a really promising AI project get completely bogged down, stuck in some endless pilot, or just outright fail an audit? It's almost never about the model's performance. It's because security and compliance were an afterthought. We're here to flip that script and bake it in from day one.
So here's our game plan. Think of it as an architect's journey. First, we'll design the data blueprint. Then, we'll actually construct what I like to call the secure factory for fine-tuning our models. After that, we'll cover how to run it safely, and finally, what to do when things go wrong. We're going to plan the fire drill. By the end, you'll see how to truly architect trust into your AI systems.
Okay, let's get into the most critical phase, designing the data blueprint. Now, this is where the real work happens, long before you spin up a single GPU or even look at a line of data. We have to stop thinking like coders for a minute and start thinking like architects.
So let me ask you something. When you're kicking off a new fine-tuning project, what's the very first thing you do? Is it wrangling the data, spinning up your training environment, setting up the configs? I bet the real answer is going to surprise you. The answer is none of those. In a truly secure, scalable system, the very first step is to build a threat model. Yeah, that's right. We put on our black hat for a minute and we brainstorm every single way this thing could blow up in our faces before we've even started. This isn't about being negative, it's about being a professional. And look, a threat model doesn't have to be some 1,000-page document that nobody reads. It can be a simple, powerful table just like this. You take an asset like your training data. You identify a threat, maybe an inversion attack where someone tries to pull private info out of your model's predictions. And then, and this is the key part, you define a concrete technical mitigation. This simple exercise forces you to think ahead and stops you from flying blind. So one of those mitigations is a data sanitization pipeline, and this is absolutely non-negotiable. We never ever trust a model to just ignore PII. Hope is not a security strategy. Instead, we build automated controls, a digital bouncer, like this little Python script, that physically removes sensitive data before it ever gets near the model. It's not a manual step, it's a mandatory automated gateway. And here's another automated gatekeeper. Think of this JSON blob as a passport for your data. Every single dataset gets one. It says what it is, its classification, and whether it's approved for use. Our training system is then architected to check this passport, and if the passport isn't valid, if approved is false, the job just fails, automatically. No human can overwrite it. That is how you enforce security by design. Okay, so our blueprint is done. We know the risks, we've got our data controls in place. Now it's time to actually build the factory, the secure environment where we're going to fine-tune these models. Let's look at the key components. The absolute foundation of a secure factory is the principle of least privilege. In simple terms, nobody gets the keys to the whole kingdom. We use role-based access control to give people just enough permission to do their job and nothing more. The data engineer can upload data, but they can't train a model. The ML engineer can train a model, but they can't deploy it. You create separation of duties, and you dramatically reduce your risk. Now, this highlights a critical architectural decision. The old way of doing things, direct fine-tuning, is incredibly risky. It's like performing open heart surgery on your multi-million-dollar model every single time. One bad training run could poison the whole thing forever. The modern secure approach uses techniques like PEFT and LoRa, which are a total game changer. They let us tweak the model's behavior using these tiny isolated adapters, while the massive base model stays locked down, completely immutable. And this is what that isolation looks like in practice. Your core, expensive base model is pristine. It's untouched. Then you just attach these lightweight, specialized adapters for different tasks. And here's the beauty of it. The blast radius is tiny. If the sales adapter goes haywire or starts leaking YADA, who cares? You just unplug it. The rest of the system is completely unaffected. When you're managing hundreds of these, this is the only sane way to operate. And just like we rigorously test for model accuracy, we have to rigorously test for privacy. We don't just hope the model won't leak data. We build specific tests into our evaluation suite designed to trick it into doing just that. We ask it pointed questions. And if it fails this test, if it gives up private information, the build fails. Period. It's treated with the same severity as a drop in accuracy.
So our factory is built. The production line is running. Fantastic. But now, how do we prove it's secure? How do we satisfy the auditors when they come knocking? And how do we make sure we're operating safely out in the real world? This is where our operational controls come in.
This right here is non-negotiable. Every single important action, who trained what model, on which dataset, at what time, is automatically logged in a structured, unchangeable format. The real magic of this is what it does to audits. Audits are no longer a week-long nightmare of pulling engineers into meetings. They become a 5-minute database query. I mean, think of the time and sanity that's saved.
Now, this is a really important concept for us as engineers. We don't implement laws like GDPR. We're not lawyers. What we do is we implement technical controls that satisfy those laws. A requirement for data minimization becomes a concrete engineering task. Build a masking pipeline. Access traceability for SOC 2, that's our immutable audit log system. We turn abstract legal problems into concrete engineering problems that we can actually solve with code. Okay, our final layer of defense is right at the edge, at the point of inference. In production, we wrap our model adapters with runtime controls. This is stuff like rate limiting to stop abuse, or a policy guard that acts as a final safety net on the model's output, making sure it doesn't say something it shouldn't. These are the security guards standing at the factory gate, checking everything that comes in and out.
Let's be real for a second. No matter how perfectly you design your system, incidents are going to happen. It's inevitable. A mature architecture isn't one that never fails. It's one that's designed to recover gracefully and quickly. You have to have a plan before the fire starts.
And this is where all that architectural work we did up front pays off big time. Because we used adapters to isolate everything, an incident isn't a 5-alarm panic. It's a calm, rehearsed procedure. Step 1, you instantly disable the single affected adapter. The rest of the system keeps running. Then you can use your audit logs to see what happened, fix the data, and retrain. We're talking about a full rollback in minutes, not the days or weeks it would take if you had to fix a contaminated base model.
So if you walk away with just one single idea from all of this, let it be this one. For us, the engineers, the architects, the people building these systems, security and compliance are not abstract ideas in a legal document. They are concrete, automated, enforceable technical controls that we design and build directly into our pipelines. We are the first and the most important line of defense. And that brings us to the final question I want you to ask yourself. When you look at your own AI systems, are they built on a checklist? You know, a bunch of boxes you tick after the fact to make the security team happy? Or have you truly built security into the core architecture from day one? The difference between those two approaches is the difference between systems that scale and systems that fail. The choice is yours. Thanks for tuning in.